Hey, this is Dr. B, and in this video we will solve two brief problems that relate equilibrium constants regarding concentration to equilibrium constants regarding pressure, otherwise known as Kc and K sub p. Without deriving the formula, we're going to present it directly, and there it is. The equilibrium constant regarding pressure is equal to the equilibrium constant regarding concentration, multiplied by R, which is just a number. It's the 0.0821 form of R, the non-energy form of R, times T, which I'm sure must be Kelvin, and times the change in the number of moles. That's products minus reactants. So here's a reaction where carbon plus carbon dioxide is making 2 moles of carbon monoxide. There's your K sub p value. Calculate Kc at 25 degrees Celsius. Pause this if you like now, solve it yourself, and compare it to what you see. And by the way, make sure this is for everything has to be a gas. We'll omit anything that is not in a gaseous form, and that applies here. So when I see this, I'm going to say to myself, well, can I just plug into this formula? I'm given this, I'm given R, I'm given T, and delta N is going to be 2 minus 1 because I'm going to put a slash for this. I think that's a plug-in one. There's the R, and there's the T. And there you go. Plugging in directly, I have my numbers. I was very careful to write my liters atmosphere over mole Kelvin. I got my 2 minus 1, and the answer is 0.0777 with no units at all. Let's try another one. Go ahead and read this, figure out how you're going to solve it. Maybe see how you go ahead and read through it and see what you can glean from it as you go and then solve it. I always find that helpful. It makes me confident when I go ahead and write things down. Okay, I'm reading that the dissociation of calcium carbonate, that's chalk, has an equilibrium constant of, not too bad, at 800 C. Wow, that's really hot, but I know I'll be ignoring that. And I know I have a formula for K sub C. This is a K sub P versus K sub C reaction, so I'll ask myself if I can just plug in. K sub P is given, wonderful, and it's going to be equal to R, which I always have. I had T, I'm going to change that to Kelvin, and it's just then times the change in the number of moles, and for here it is, ooh, what do I do when there's none there? Well, you just call it 0. This would be 1 minus 0, which is 1. So I believe I can plug in directly, and I do. I remembered to do 1 minus 0. I remembered to add 273 to my Celsius, and you've got a very low equilibrium constant regarding concentration. This is 2 solved Kp versus Kc